So in the past, we've already talked about Venn diagrams and sample space diagrams as a way to organize our data. Tree diagrams are the last one we're going to talk about. So tree diagrams we want to use when there's more than one event versus sample space where it had to be exactly two. This could be any number of events. It would just make a larger tree diagram, okay? So let's just go right into an example. We're going to start with an example that has with replacement. And then we'll do one without replacement so you can see the difference between the two. All right, so we have a bag of marbles. 5 of them are yellow, 3 are green, and 7 are blue. Sam's choosing a marble, putting the marble back, and then choosing a second marble, okay? So the key here is that she's returning the marble, okay? That's what makes it a with replacement problem. So because she's returning the marble, these events would be independent, right? One doesn't impact the other, because it has the same number of marbles after you return the first one. So that means our probabilities are going to stay consistent, which makes it a little bit easier. So in this example, when she first is choosing a marble, there are 3 options that she could get. So I'm going to draw a tree diagram. All right. So she's able to choose either a yellow marble, a green marble, or a blue marble. And then when we're looking at this, it says 5 are yellow, 3 are green, and 7 are blue. So 5 are yellow, 3 are green, 7 are blue. And we want to put the probabilities. So if we add those all up together, that's a total of 15. So 5 out of 15 chance she gets a yellow, 3 out of 15 she gets a green, and 7 out of 15 that she gets a blue, okay? This represents the first time she picks a marble. After that, she puts it back, and then she picks a marble again. So on this branch right here, we're gonna assume that she chose a yellow marble first. Now the second one can either be yellow, green, or blue. And because she put the marble back, they have the same exact probabilities of happening. So 5 out of 15, 3 out of 15, and 7 out of 15. And that's going to be the case for all 3 of these. So yellow, green, blue, yellow, green, blue. She could have chosen a green first and then yellow, green, or blue, and then yellow, green, or blue. Okay? Make sure you give yourself enough space, unlike me, so that you can fit it a little bit nicer. All right, so again, this is just an organizational tool to represent all of the probabilities or our full sample space. So now I can list out all the potential options pretty methodically. So if we follow this first branch here, this one starts with her choosing a yellow. So after the yellow, she could then choose another yellow. So I'm going to put the probability that she chooses 2 yellows. And then we're going to take the probabilities on those branches and multiply them together. So 5 over 15 times 5 over 15 is 25 out of 225. Okay. Following that same branch, we could have chosen the yellow first and then the green. So probability of yellow then green would be 5 out of 15 times 3 out of 15. So 15 out of 225. And then lastly on this branch, we could have chosen yellow first and then the blue. Probability yellow then blue would be 5 out of 15 times 7 out of 15. And that'd be 35 out of 225. Okay, we're going to go through and do that for each branch. So now we're starting with the green branch. So we're going to go green, yellow. Of green, yellow would be 15 out of 225. Again, that's multiplying that and that one. Probability of green then green is going to be 9 out of 225. Probability of green then blue, 21 out of 225. And then my last branch down here, the probability of blue then yellow is 35 out of 225. Probability of blue then green is 21 out of 225. And finally, blue and blue is 49 out of 225. All right, so this represents all the possible options that we could get, which then allows us to find different probabilities. So now that we use the tree diagram to find all the probabilities, we can now use those probabilities to answer these questions. So I just copied them from the last slide. These are the same ones we just found. So now if we wanted to find the probability that she selects at least one yellow, then we're going to just look at all of these results and find all the ones that have at least one yellow. So that would include this one, this one, this one, this one, and this one, okay? So then we just add all of our probabilities together. So we'd have 25 out of 225 plus 15 out of 225 plus 35 out of 225 plus 15 out of 225 plus 35 out of 225. And if we add that all together, that's 70 plus 30 is 100, so 125 out of 225. Okay, and then we can simplify, so that would be 5 out of 9. All right, so for the second one, we're trying to find the probability she selects a green given the first is not yellow. So for our given formula, it's A given B is the probability of A and B over the probability of B. Okay, so first thing we want to do is figure out she selects a green and the first is not a yellow. She's selecting a green and the first is not a yellow. So it can't be any of these options because all of those, the first are yellow. So a green and the first is not yellow would be here, here, and here. And then also this one, okay? So we're just gonna add all those together. That was the intersection. So 15 out of 225 plus 9 out of 225, 21 out of 225, and 21 out of 225. All over the probability of B, which in this case is that the first is not yellow. So that's also going to include this one and this one, okay? So in our denominator, we'd have all of the ones that don't have the first marble yellow. So 15 plus 9 plus 21 plus 35 plus 21 plus 49, all out of 225. All right, so let's simplify that. So for our numerator, let's see. For our numerator, we get 66 out of 225 over our denominator, we get plus 21 plus 49 is 150. 150 out of 225. If you remember dividing fractions, this is really 66 over 225 times 225 over 150. So the 225s cancel out, and it's just 66 over 150. Okay, and we can simplify this. This would be 33 over 50. So now let's look at an example without replacement. Sophia has a bag of 8 blue pens and 2 purple pens. She randomly chooses a pen to write with. Jake then asks to borrow a pen, so she passes him the bag so he can randomly choose one as well. So now we're going to create a tree diagram for this situation. All right, so first event that happens is Sophia is choosing a pen, and the pens she has to choose from are blue or purple. So Sophia chooses a blue pen, or Sophia chooses a purple pen. The probability she chooses a blue pen would be 8 out of the 10 pens total. Purple would be 2 out of the 10 pens total. All right. After that, she's already chosen a pen, so that pen is no longer in the bag when Jake goes to choose his pen. So after she chooses one, we're going to assume on the first draw that Sophia chose a blue one, okay? So now when Jake goes to choose between purple and blue, how many blues are left for him to actually choose from? So since Sophia already took one out, now there's only 7 blues, and in the bag there should only be 9 pens left. Okay, there's still 2 purples out of the 9 pens total. If we go the other branch, this is saying Sophia chose a purple out of the bag. Then similarly, if she had originally chosen a purple, there would still be 8 blues, but only 9 pens total. And there would only be 1 purple left out of those 9 pens total. Okay? And then after this, it's the same process as before. So the probability that Sophia chooses a blue and Jake chooses a blue is going to be 8 over 10 times 7 over 9. So 56 over 90. The probability that Sophia chooses the blue and then Jake chooses purple would be 8 over 10 times 2 over 9, so 16 out of 90. The probability Sophia chooses purple and Jake chooses blue is 16 out of 90. And then they both choose purple would be only 2 out of 90. Okay? And now we can do the same thing and answer questions about this situation. So if we wanted to know, this would be part B. If we wanted to know the probability that, we'll start with they choose different colors. Different colors. So again, we're just going to look at all of our results. So in the first one, they both choose blue. In the second one, different colors. In the third one, different colors. So we'll just add those two together. 16 over 90 plus 16 over 90 is 32 over 90. Oops. And then let's do a given one again just to get some practice with that. So the probability that, let's do Jake chooses blue given they chose different colors. Okay. So again, conditional probability is the probability of A and B over the probability of B. So we're going to look for Jake choosing a blue and them being different colors. So Jake choosing a blue and them being different colors is this one and only this one. So that's our numerator. And then the probability that they're different colors, we just found that in the last part. So that was 32 out of 90. So this would be 16 out of 32, which is 1/2. And that's it. All right, so let's try a different type of problem that looks a little bit differently. This one's kind of harder, but we'll go through the process. So this time we have Lily's playing tennis. In tennis, if you miss your first serve, you have a second chance to serve again. So the probability that Lily wins the point if she makes her first serve is 0.75. The probability she wins the point with her second serve is 0.55. She makes the first serve 3 out of 5 times and the second serve 3 out of 4 times. So there's lots of things going on here, okay? So the very first thing that Lily would have to do is serve. So we're going to first look at the first serve, okay? So for the first serve, she either gets it or misses it, right? So this would be first serve is a success, first serve is a failure, okay? The probability that she got her first serve was 3 out of 5. So what would be the probability that she misses her first serve? Because it doesn't tell us that right out. We know that if 3 out of the 5 times she gets it, that would leave 2 out of 5 times that she would miss it, okay? If she gets her first serve, then she doesn't do a second serve, right? Because she made it, so they just keep playing. If she doesn't make her first serve, then we have the opportunity for a second serve. So it would be second makes it, or second serve does not make it. Okay. So that's where this one got a little tricky. So for the second serve, it says that there's a 3 out of 4 chance that she'll make the second serve, which would leave a 1 out of 4 chance that she misses the second serve. All right, now that we have the serves out of the way, we can look at the points specifically. So it said in the beginning that if she makes her first serve, which she did right here, then the probability that she wins the point, wins versus loses, is 0.75. So she wins is 0.75, which means she would lose 0.25. Okay? All right. And then it says if she makes her second serve, which happened over here, the probability that she would win is 0.55, which would mean the probability that she loses is 0.45. Okay, again, those should add up to 1 total. That's how I'm getting the losing number. And then lastly, we just need to think about this logically. For the second serve, if she misses the second serve, can she even win the point? No, okay? So she can't win the point, so she would have to lose the point the whole entire time. 1 out of 1 times, or 100%. All right, so that one was tricky. But let's go ahead and write our results. So if she makes the first serve and wins the point, that would be 3/5 times 0.75, which we could write 1 as a decimal or 1 as a fraction, but either way, which would be 0.45. The probability that she makes the first serve but then loses is 3/5 times 0.25, which is divided by 5, 0.15. Okay, so we did both of these ones. Now we're on to she doesn't get her first serve. So the probability that she makes her second serve and wins would be she doesn't get her first, she makes the second and wins. Okay, so it's going to be 2/5 times 3/4 times 0.55. So that equals 0.165. The probability that it's a second, she gets the second serve but then loses the point, is 2/5 times 3/4 times 0.45, which is 0.135. And then the probability that she misses, right? Misses completely. So 2/5 times 1/4 times 1 would be 2 out of 20, which is 0.1. Okay. So those are all the possibilities. Again, that one was a bit tricky. And then we could answer probability questions based on these results. Okay.